Hello and welcome to the Bulletin with UBS on Monocle 24. Each week, the sharpest minds and freshest thinkers in finance take you beyond the numbers and hype, right to the heart of the big issues of the day. Now, if you're a regular listener to the programme, you'll be well aware that UBS is interested in addressing the big questions that shape our world. To help best answer them, they've sought out a number of Nobel laureates in the economic sciences to ask them to share insights, discuss their research, and open their ever-inquiring minds. This week, we're lucky enough to be joined once again on the show by one of these laureates, the brilliant Daniel Kahneman, who's spoken to us previously about the complexities of human judgment. Kahneman won the Nobel Prize in 2002 for having integrated insights from psychological research into economics, especially concerning judgment and decision-making under uncertainty. Up for discussion this time was his newest book, Noise, a Flaw in Human Judgment, and the idea of how noise infiltrates different parts of society. It was a huge pleasure to welcome the great Daniel Kahneman back to the programme. We began our discussion by diving into what inspired this work.
The whole project of noise began 8 years ago now, or a little more. It began when I was doing some consulting work with an insurance company, and I ran what we now call a noise audit. That is, I presented some 50 underwriters with the same problems. And we looked at the variability, and I asked executives the following question. If you take two underwriters at random, and they've looked at the same problem, by how much do you expect them to vary in percentages? So that you take their two judgments, you compute the average of the two, you compute the difference, you divide the difference by the average. How large is the difference relative to the average? And it turns out that people have a standard answer to that question. They think about 10%. Looks reasonable. We know that judgment is involved, so we don't expect perfect consistency. 10% looks about right. But in that study, the correct answer with underwriters was about 55%. More than 5 times greater than the executives of the company expected. And that's how the book was born. It was born really because the problem was completely ignored in the organization. The insurance company, they were completely unaware that they had a noise problem.
I asked Kahneman to walk me through what noise means to him and how it differs from, say, a judgment, bias, or simply personal opinions.
In order to distinguish noise from bias, you really have to go back to define judgment as a kind of measurement. So we actually define judgment as measurement with a measuring instrument in the human mind. When you think of measuring the length of a line, for example, with a very fine ruler and doing it multiple times, then you're going to observe that you do not get the same measurement every time. There is variability. That variability is called noise. If you know the exact length of the line, for every measurement you can determine what the error is, and you can compute the average error. The average error is the bias, and the variability in the errors, that's noise. But I should add that there's a real problem with the word bias, and there is a real problem with the word noise. And this is that they're used in many different meanings. So, for example, when we talk about a psychological bias, we sometimes think of the mechanism inside the mind that produces errors, and that's not the same thing as an average error. And similarly, noise is a terrible word in that we use the word noise for any kind of uncertainty in addition to using it for physical noise. Judgment in general is like measurement. It's the assignment of a value to an object on a scale. You judge probabilities, you judge sizes, you judge numbers, but a judgment is quite specific. Underwriters decide on premiums, bankers decide whether or not to approve loans, physicians decide whether or not to operate, and these decisions are really special cases of judgment. You put a value on something or you allocate an object to a category. Some judgments can be verified. If you make a prediction about the weather tomorrow, all you have to do is wait one day, and then you'll know the weather. So that can be verified. On the other hand, if you make a prediction about the weather 60 years from now, for practical purposes, this cannot be verified. And many professional judgments really cannot be verified. If a judgment were guided by exact rules, it would not be called a judgment. So what makes it a judgment is that there is some uncertainty. Otherwise, it would simply be called a measurement or a computation. But when there is some uncertainty, some genuine uncertainty, where reasonable people can have slightly different opinions, that's a judgment problem. Differences among people become problematic when they're undesirable, and there are contexts in which differences among people are perfectly fine and in fact desirable. I would not want all the film critics that I read to have exactly the same opinion. I want some variability. On the other hand, when you have a justice system and you have judges passing sentences on defendants, if you know that different judges would pass different sentences on the same crime, that is a problem. In principle, you would want the justice system to speak in one voice and the banking system to speak in one voice. You would want the decision made in an emergency room not to depend on the particular physician who is on duty at that moment with that person.
When looking at bias and noise, I wanted to know which Kahneman found to be the more problematic, but also why these elements are so invisible to us when making decisions.
The beauty, I think, of thinking about judgment as measurement is that there is a theory of measurement, and we know how to measure overall accuracy. And in fact, the modern solution is more than 200 years old. In that solution, there is a global measure of inaccuracy, a global measure of error for a set of measurement. And there is a formula, which I think is a very important formula. And the formula is that global error of a set of measurement is equal to the square of the bias plus the square of the noise. So bias and noise, in principle, have similar weights when you're thinking of accuracy. Now, in practical terms, my guess is that in many situations, noise is much larger than bias because there is a huge amount of noise whenever you measure it. It's quite rare that we have the occasion to measure noise. And in order to measure noise, or to carry out what we call a noise audit, to carry out a noise audit, you have to present the same problem to many people. They have to make independent judgments, and then you have to look at the variability of these judgments. Or in some conditions, to measure another kind of noise, you would present the same person with the same object on multiple occasions. For example, a radiologist could be shown the same X-ray 1 week apart without knowing that it's the same X-ray, and you look at the variability of judgments. Now, this very rarely happens. In most cases, you have an underwriter setting a premium, a banker approving a loan or not approving it. So we don't have all that many occasions to observe noise. Sometimes, when we have a committee making a decision, in principle, you should observe noise because the members of the committee are not compelled to agree. But in fact, there is so much conformity within discussions of groups that people have such a strong tendency to agree with each other that when people talk, you get an underestimate of noise. And this happens in various ways. So, for example, in committees, somebody who has a view that is very different from the views of other people is likely to stay silent because it's uncomfortable to be different from other people. What makes noise difficult is that whenever I make a judgment, whenever I have an opinion, whenever I look at something in the world, I think I see it correctly. I think I see the world it is because that's the way it is. I see the world as I do. And so this confidence that people have in their judgment, part of it means that they expect other people to agree with them much more than people actually do. And this has a technical term, it's called false consensus. That is, I think that other people would agree, but in fact they agree less than most of us think.
With all the research into noise and with the in-depth look at certain professions, what would an extreme consequence of noise look like in real day-to-day life?
The most dramatic example to my mind is the justice example. And there has been a lot of research in what I called noise audits before, where you present multiple judges with the same case and you look at the variability of their judgment. And the variability is really appalling. I mean, for the same case, you can get sentences that go from 15 days to 15 years. And just to give you an example of how large the problem is, if you take a particular case, a crime and a defendant, and you have judges evaluate it, this was an experiment done many years ago with American federal judges, 208 of them, for a crime where the average sentence was 7 years. If you took two judges at random and you look at the average difference between them, the average difference was 4 years. So that means that a defendant coming before a judge is really facing a lottery, and I would say an intolerable lottery. And to a significant extent, this happens not only in the judicial case, this is the more dramatic, but it's very similar in the ER. Depending on the physician that you see in the ER, many different things are going to happen to people. There are systematic differences in the behavior of physicians when they are fresh and rested early in the morning and late in the afternoon. So late in the afternoon, they make easier decisions. They give more opioids, they give more antibiotics, they give more tests, they do what's easier. And that is a source of occasion noise, because from the point of view of the patient, unless you know that you want to get the physician at the physician's best, you normally don't care what hour you get the appointment. But the hour at which you get the appointment is a source of lottery, because the physician is going to be in different states.
Are there noise reduction or elimination techniques that could be shared for individuals or for organizations?
When you're thinking about biases and how to reduce biases, it's as if you were thinking about a particular disease, and then you're looking for medication or you're looking for a vaccine, and the medication and the vaccine are specific to the problem that you have, to the bias that you want to control. But there is another way of looking at it. When you wash your hands, which is hygiene, you don't know which diseases you are preventing. And if you are lucky and successful, you will never know. And so the equivalent, we call procedures decision hygiene, which are procedures that are not intended to deal with particular biases, but they're intended, if at all possible, to generally improve judgment, to reduce error, to reduce both bias and noise. And we call those collectively decision hygiene. The word hygiene is not very exciting, but we picked it deliberately because washing hands is actually very useful to health, and decision hygiene, that's the model that we want to think about. So there are a set of procedures that can improve judgment in a general way. We listed a few. Great deal of research is needed about how those work and how other procedures of decision hygiene might work. I'll give you one example to make that a little more specific. When, for example, you are going to hire a candidate, so you're going to interview a candidate, what is the best way of doing that? And it turns out we know the best way. It's not that people are very good at guessing how well people will perform on a job, but we know that some ways of doing it are much less accurate than others. The least inaccurate ways involve breaking up the problem into multiple dimensions. Instead of running an interview in which you, in a general way, try to understand the other person and form a global impression of the other person, you do something entirely different. You look at what are the relevant attributes, what are the relevant dimensions that I want to learn about, and you interview about those dimensions one at a time and independently of the others, and you score them in each, when you finish a section of the interview, you give a score to that particular dimension, and then you move to the next dimension. And you try not to think of the final conclusion. So we call that delaying intuition. And this we know is the optimal procedure for selecting candidates. If you stop to think about it in general when you're making decisions, you can think of options as candidates. So you can think of what are the dimensions that would make one option better than others. And you should be thinking about these dimensions one at a time and delay intuition and delay the formation of a general opinion. And there is a principle here, a statistical principle that is extremely important, and it's the principle of independence. So if you want underwriters or people in a meeting, you want them independent of each other. If you're going to collect witnesses to a crime, you don't want them to talk to each other. You want to talk to each of them separately and not allow them to communicate. That you maximize information when you make different aspects of the information independent of each other. And assessing the different attributes of a problem separately, making them independent of each other, is very useful. When you're going to have multiple people looking at the same candidate, you want the people to be independent of each other. And there are companies that do it right. For example, Google has procedures of selecting people that probably are as good as anybody knows how to do. I have heard of venture capital firms that have a process that is similar to the process where they break up problems into attributes and they keep track of the quality of their decisions and they evaluate options they didn't choose. So they follow on what happens to decisions they did not make, and that can be very instructive.
I asked Kahneman where the research goes next. Can we implement the learnings and lessons within noise to measure the costs of noise and do so quickly? According to Kahneman, we've only scratched the surface.
We're at a fairly early stage, and that I think is quite important. And I would even say that the book that we wrote, from my point of view, is premature. That is, ideally, with an idea and a problem of this size, you should spend 20 years thinking and researching about it before you write a book. But I was 80 when I began, and I didn't have 20 years. And so there are many things where we have opinions and we have guesses and we have hopes, but where a lot of research is needed to establish the validity of what we're proposing.
Extraordinary insights from the brilliant Nobel Prize-winning economist Daniel Kahneman there, wrapping up this latest very special edition of the Bulletin with UBS here on Monocle 24. Find out more and delve into the archive of past conversations with other remarkable laureates at monocle.com. And to read more from and about Kahneman, and to discover how Nobel perspectives shape the UBS worldview, head to ubs.com/Nobel. This is the Bulletin with UBS on Monocle 24. I'm Tom Edwards. Thanks for listening.